Seems like it worked.
It actually worked at that power.
When Columbia University engineering professor Hod Lipson envisions the kitchen of the future, he sees 3D printed food cooked by a laser beam. And based on research being conducted in his lab, that reality may not be far off.
People always wonder, will 3D printing ever make it to people's homes? Will people want to use a 3D printer at home to make things? And actually, if you think about this, most people don't make anything at home except food.
Lipson points out that cooking, unlike many areas of everyday life, hasn't changed much with the advent of computer software, but he thinks it will.
So, we started with this work about a decade ago. In the beginning was a sort of a frivolous activity. We would really focus on printing with engineering materials, but we would test the printers with chocolate, with peanut butter, with cookie dough and things like that. But we soon realized that actually printing in food is more than just a frivolous activity. It's actually very interesting. It has a lot of potential, both for making novel kinds of foods, but also for making more healthy foods, because you can start controlling the food content using data.
Data about a person's body and health. This information could be used to find and print the ideal meal for his or her needs.
What will happen is all of these biometric devices that you wear, your iWatch, your personal genome that's online, that's been sequenced, all that information, all that data will feed through various AI systems that will be able to recommend what you need to eat that morning.
In other words, information about a person's DNA, nutritional intake, or daily habits would provide a blueprint of what should be in his or her food. The user could then, for example, look up a meal that meets those needs. Cartridges filled with various ingredients would be combined automatically following the recipe's instructions. Lipson says the implications of this could be huge. Imagine running a race having eaten a scientifically selected breakfast to maximize energy, or being able to precisely implement a doctor's dietary recommendations. Beyond that, people with limited access to food could use what's available to them in different ways. Food waste might decrease by people only making what is needed, and the ability to create a favorite chef's recipe could be right at a user's fingertips. Cooks could even get creative with presentation. For example, this walnut and sesame paste is printed in the shape of a pyramid. But in his research, Lipson quickly discovered a barrier to entry he didn't anticipate. People like to eat food they can identify.
In the first couple of years, we started exploring this idea of printing with more food sciencey materials. The sort of unpronounceable ingredients you see in some foods that you buy. But we quickly abandoned that because we saw that with a machine like this, we can create incredibly interesting foods that are food safe, they're even healthy, but nobody will want to try them. They were sort of crazy, purple cubes that tasted like broccoli with a milk texture. So we scaled that project back and we went and continued to work with basic ingredients like oil and water and flour and butter and chocolate, and things that people recognize.
Another challenge, the printer relies on food design software that doesn't fully exist yet.
Most of the design software that's out there is for editing images or for editing engineering drawings, but not for editing food. So we have to basically develop this whole ecosystem of software tools that can do that.
Primarily, Lipson and his research team are focusing on perfecting the printer itself. While there are a few 3D food printers on the market now, they're limited in what they can do. Lipson wants the printer he's developing to be able to switch automatically between a number of ingredient cartridges. So far, it can only handle up to 8. The final product needs to be consumer-friendly, too.
This is one of several printers that we have, and we've built multiple printers over the years. One of the things that we've noticed is that when we take this sort of lab contraption into a chef, they will look at this and they say, this is great, but no way will this ever make it to market. We're never going to have a thing like this on a kitchen counter. When we think about how a food printer might actually look like when it is on your counter a few years from now, it will look more like an espresso machine. It will be stylized. All these devices will be hidden.
Lipson has a prototype of what that could look like, but there's still a long way to go. Meanwhile, he and his team are working to expand the machine's functionality so it can cook food as well as print it. This would allow them to, for example, not just print in cookie dough, but also bake the cookies.
We are not only working with new kinds of ingredients, but new kinds of cooking processes. So not just conventional heat, but also infrared light bulbs, lasers, and so on. And these sort of combination of the ability to integrate lots of ingredients and cook them in a software determined way really allows us to explore a new food space. Frankly, I'm really looking forward to the sort of kind of culinary innovation that we'll see when this then becomes ubiquitous.